So far we have seen that if a n digit number in any base b is given, okay, and if this is the ith number in that base, then you can get the value of I using the digits of the number. You can get the value of I using the digits of the number, as every digit has some weightage. Every position has a weightage, and by weighted sum of the digits will give you the value of I. Okay, now just think about this. Number system was devised for what? Number system was devised for counting. Okay, and like I said, that human beings, we have taken the standard is decimal number system. But what are we doing from the last few videos is to find out the value of I. And what is this I? This I is nothing but how many numbers have passed to reach at this number. Okay, so basically we have just counted the numbers that have passed to reach at this particular number. So you are counting in terms of what? If you say that, okay, this is the 50th number in this number system, then what is this 50? This is in terms of your decimal number system. So if you understand what we actually did, what is this I? This I means, okay, if the value of I is, let's say, 100, what does it mean? It means that this is the 100th number in this number system. Okay. And if this is the 100th number in this number system, then what is the 100th number in decimal number system? I itself. This I that you got is nothing but the decimal equivalent of this number. Okay, so if this is the number in base B, its decimal equivalent is I. I hope you get this point. Decimal equivalent of any number in base B. How can you get it? How can you get it? Just find the ith value is nothing but the decimal equivalent. The ith value is nothing but the decimal equivalent. The ith value is nothing but the decimal equivalent. Right? So if you are given, let's say, 64 base 8. So this is a 64 base 8. Okay, so this is octal. Okay, this is an octal number. What is the equivalent decimal number? How can you get it? Just expand this 64. So 6 into 8 to the power 1 plus 4 into 8 to the power 0, which will be equal to 52. 6 is a 48 plus 4 into 1, 4, which is equal to 52. So what is 64 in base 8 is 52 in base 10. This is how you can find decimal equivalent of any number in base B. Okay, let's say we take one example of a hexadecimal number, which is, let's say, AB 2 in hexadecimal. What is the equivalent in binary? Also, what is its decimal equivalent? So just expand it. Then it will be A into 16 to the power 2 plus B into 16 to the power 1 plus 2 into 16 to the power 0. So this is equal to A. A is equivalent to 10. So 10 into 16 to the power 2 plus 11 into 16 to the power 1 plus 2 into 16 to the power 0, which is equal to 16, 56, 256. 256 into 10 plus 11 into 16 plus 2 into 1, which is equal to 2560 plus 176 plus 2. Okay, whatever the answer is, this will be the decimal equivalent. If I take another, okay, take one decimal number itself, 784 base 10. What is the decimal equivalent? Of course, it will be 784. But how do you find the ith value? Just verify it. Of course, it has to be 784, but verify it. So 7 into 10 to the power 2 plus 8 into 10 to the power 1 plus 4 into 10 to the power 0, which is nothing but 700 plus 80 plus 4. So we are doing this, all of this calculation or counting that you are doing, that is in terms of decimal number system only. So I will just recap it once, and this is finished. And this video will be titled as decimal equivalent of any number system. Okay, of any number in any base. Somewhat like that. Okay, what we have done so far is, what we did previously is that we found out that if this is the n digit number in any base, and if this is the ith number in that base, we found out what would be the value of I. Arbitrarily, we take an n digit number in any base. Now this n digit number is supposed to be, let's say, ith number in that base. If this n digit number is supposed to be ith number in that base, then we try to find out how to calculate this I, and we got that each position in any base in a number, each position has a weightage, and the weighted sum will give you the value of I. Okay, if this value I gives you that this is a 200th number in base B, okay, or if this is the ith number in the base B, or if this is 500th number in the base B, it means that the decimal equivalent is 500. It means that decimal equivalent is I. Okay, just do the weighted sum and you will get the decimal equivalent of the number. And this is the story that I think I should end this video now. In the next video, we will see how to, if a decimal number is given, how can you find the equivalent number in any other base. Thank you very much.